Hello everyone. With our revision of upcoming prelims examination right there at home, we want to take the continuity of the study of oceans as we started with the first video that I have uploaded on it. The study of ocean, apart from hydrological cycle, ocean water salinity and temperature, is also the study of ocean water movement. And as I confine our study and revision with the general studies orientation with NCERT, it is the next chapter of NCERT that will be our base, and we'll be now learning sea waves, ocean current system and tidal mechanism one by one. And be informed, largely in geography we take terrestrial study, as in geography is the discipline that is oriented towards study of planet Earth. Celestial studies is not the domain of geography, but because geography deals up with precisely everything that is going around us, it is that tide or tidal mechanism makes an excellent example of the study where we have got celestial connectivity to us, because it is lunar solar attraction that facilitates the tidal bulge. So by default a slight deviative approach of study, remaining at NCERT level, helping you with your revision of your upcoming 2020 prelims examination. So let us get with our next chapter in the study of oceans, that is ocean water movements, sea waves, tidal mechanism and oceanic current system. Right, so we begin with our study of chapter movements of the ocean water. And what are the movements of the ocean water that we have to take into account? It includes three different movements, as I mentioned. One is called sea waves, two is called tides, and three is called ocean current system. Each one of them involves certain different mechanism altogether, beginning from NCERT content. It reads, the ocean water is dynamic, which has got the variations in its temperature, salinity, density and the external forces like sun, moon and the wind that influences the movement. The movement of ocean water has to be taken with the three defined characteristics. Now if I read the next line, which reads, numbering it as number 1, the horizontal motion refers to the ocean current and waves. So if I take sea waves and oceanic currents, we are actually talking about horizontal movement of ocean water. The vertical motion refers to tide. So tide is defined to be the bulge that is developed on the water surface due to lunar and solar attraction. So we are actually distinguishing them. And then there is a minor definition that is being given, though it is not complete. So ocean currents are the continuous flow, read this, ocean currents are the continuous flow of huge amount of water in a definite direction, while wave are the horizontal motion of water, where water moves at the place. If you read these lines, it very clearly gives me that if I take waves and currents, I can combine them to be the example of horizontal movement of water. But if I talk about oceanic current, it's a continuous flow of huge amount of water in a particular direction. However, when we talk about waves, it is that water moves ahead from one place to other. Only in case of currents, water in wave does not move, but the wave trains move ahead. This is very important thing, and that is what we'll be learning one by one. And then when we talk about the tides, it says, due to the attraction of the sun and the moon, the ocean water rays up falls down twice a day. The upwelling of cold water from subsurface and sinking of surface water also forms vertical motion of ocean water. So I have got two types. From this first paragraph of our chapter, what do we conclude? We conclude that the movement of ocean water is one horizontal and two vertical. Horizontal movement of water includes waves and currents, and vertical movement goes with the tides and also with upwell and downwell, which we'll be talking about with subsurface current system. So I have got 4 different types of movement to be learned if I count it like this. But if we take the reference of the study which is oceanic current system, so it comes very clear that oceanic current system incorporate the study of upwell and downwell as well. Now we want to take the study one by one of each of the movement. As per our NCERT, the first movement is of sea wave. If I read just the first statement of sea waves as written in our NCERT, waves are actually the energy, not the water as such, which moves across the ocean surface. Water particles only travel in small circles as the wave passes. Wind provides energy for its movement. Now, in order to understand this, I want you to take reference of this particular image. If we see the characteristics of waves in this image, you can easily understand the terms that we utilize in the general sea waves or the movement. As we read from NCERT, it says that it is energy that is moving, because if I take the movement, if I take the wind drag, supposedly we are taking the movement of wind like this. So wind is moving in this particular direction. Drag effect of wind has created the movement of the water molecules. Now, if I take upper layer sinking and wave crest developing, so what exactly is happening is that the waves tends to rise up in the effect of drag effect of wind, and then due to gravity falls down, and it is therefore that it develops wave crest and wave trough. So when I am talking about the movement of energy, it is only creating this circulatory motion, and this circulatory orbit is rising or wave crest development due to the drag of wind, and the fall which results into the circular orbit motion is because of the gravity transfer. Thus the wave crests are developed. We know what is wave trough, and the distance between two wave crests will be wavelength. The wavelength, that is the distance between the two crests. Now it reads, orbit becomes elliptical due to shore friction showing at the base of the waves. I can notice that my wave crest is becoming elliptical. Why it is becoming so? Because the shallowness of the ocean water, can you notice that the depth is on decrease? And this is what I mentioned yesterday also in our study, that when we take reference of shoreline, it is the boundary between the land and the water. So because more I reach near shoreline, the depth of the water decreases. This decrease results in the genesis of breaking waves. Breaking waves gains height. And once the breaking waves gain height, it tends to swash. Swash is falling up of the breaking waves on shore. So remind yourself, when the sea waves are being dragged, if I am dragging the water surface with the effect of wind movement, there will be the development of wave crest, and these wave crest will become breaking waves as they reach near shoreline, and these breaking waves then tends to surf. Surfing can also be called swash. Surfing waves then quietly retreats back. So backwash is actually retreating water. So the terminology or the characteristics of waves that we correlate with can be reminded as wave crest, wave trough, wave length. Easy terms. Higher the wind velocity, taller will be the wave crest, deeper will be the wave trough, and we will have shorter wavelength. And if it is that I will be having long wave, then the wave crest will be of shorter height. Then comes in breaking waves. Breaking waves are also called breakers. What are breakers? Breakers are elliptical waves which gains substantive height because of a sort of piling up of the water near shoreline. And breakers tends to surf. Surf can also be called swash. Breaking or breaker waves then tends to return back. That retreat is called backwash. If I have to repeat the characteristics which I just mentioned of wave crest, wave trough and wavelength, let us take these two set of diagrams one by one before going to NCERT. Which are these two diagrams? Now, can you notice this diagram shows destructive wave. Destructive waves were short wavelength. Just a minute back I talked about that if wavelength is short, wave height will be great, and we can easily apply it with stronger wind drag. So, how will I define destructive waves? Destructive waves have got steeper wave front, it has got taller wave height over 1 meter. Taller wave height will develop stronger breaking waves, and these breaking waves when plunges onto the steep beach, it is directly, it's surfing. We have used the term swash or we have used the term surf. So, when there will be a strong surfing because of the higher height that it has attained, by default it will be having a stronger abrasional effect. Abrasional, the term mentioned in our NCERT, you can also read it as erosional effect. So, stronger these sea waves, destructive it will be, and these destructive waves because of its strong surfing will not just induce erosion, but also that when we talk about the retreat, the red arrow in the figure by default is showing backwash. It by default will result into the washing of all that eroded material. So, repeating one more time, what will make a destructive wave? Destructive waves are the waves that have got higher wave height, that is correlated to stronger winds. And destructive waves will be majorly related to coastal erosion. Terminology remains the same. The swash of the subsurface water, surfing, that is crashing down on shore, this will be my shoreline again, and I am on shore right here. So, you can easily take the terms to be the same, and the backwash by default will be applicable. So, destructive wave is more erosional waves. Compared to it, the constructive waves are depositional waves. Carefully see it. Low wave height under 1 meter, wave front is gently sloping, wave trough, I'll have got very little height. So, break and spills, it's not surfing. So, note here, no surfing might be somewhere inappropriate. So, in place of surfing, no surfing, we are saying it is the spilling up, the breakers, spills on shore. Now, because breakers are spilling on shore, I'll have stronger subsurface water, but I'll have weaker surfing. Water spreads over gently sloping area, imagine this to be your shoreline now, and then there will be a weak backwash. I am putting down the arrow right here, which results into the deposition. There will be continuous deposition of finer textured material. Terminology remains as it is. Please note long wavelength, lower wave height, but the terms remains the same. Wave front, wave trough, it all remains same. Elliptical wave making breaker will remain the same, only that it is not attaining that stronger height, and because it is not attaining that stronger height, its surfing by default will be weaker. And the circulatory gravity transfer, which by default is always there with the sea waves. So sea waves, one of the three movements of the ocean water, can be easily demarcated into two types. Repeating it, destructive that is erosional, and constructive that is depositional. Now we take NCERT. Most of the waves are caused by wind driving against the water. When a breeze of 2 knots or less blows over the calm water, small ripples forms and grow as the wind speed increases, until white caps appear in the breaking waves. Waves may travel thousands of kilometers before rolling ashore, breaking and dissolving as surf. Then it reads, 2. The wave size and shape reveals its origin. Steep waves are fairly young ones and are probably formed by local winds. And note it, if I take steep waves, can I call it destructive as we have seen in the image? Yes, we can. Then it is the slow and steady waves originate from faraway places, possibly from another hemisphere. The maximum wave height is determined by strength of wind, and this again we are correlating to. So slow moving will be constructive, that we can easily correlate. Now it reads that the maximum wave height is determined by the strength of wind, how long it blows, and the area over which it blows in a single direction. Once we take this into reference, we are simply reminding us with what we have learned as constructive and destructive sea waves. And then I go to the diagram. Can we notice it again? This is my wave crest, this is my wave trough, and as we take the rising here, then it falls here. So the circulatory reference we have taken, trough rising, crest is falling. Why crest is falling? Gravity. So motion of waves and water molecules, and by default we are taking wind drag like this. Wave travel, point number 3, wave travels because wind pushes the water body to its course while gravity pulls the crest of the waves downward. That is the reason if you try to see this diagram, this is how the crest is developed, and then the crest starts falling. Falling crest results into trough rising, and this is what we have seen in our circulatory motion in the diagram already. And if we take another important thing that is coming from our NCERT, so characteristics of wave, wave crest and trough, we have learned it. Wave height, we have learned it. Wave amplitude, that we have learned. See, it is a vertical distance from the bottom of trough, and it is 1/2 of the wave height. So amplitude we go it. Now wave period is merely the time interval between two successive wave crest or trough as they passes through a fixed point. Straightforward question can be made. Wavelength we are aware of, wave speed and wave frequency. Try to take difference between wave period and wave frequency. It is the number of wave passing at a given point during 1 second time interval. So it is at a given point and it is at the time. So period and frequency, period at a given point in space and frequency at a given point in time. So that is the difference that you apply. Quickly revising, what are sea waves? Sea waves actually is movement of energy which is carried on largely by winds in combination to gravity. We classify sea waves into two prominent types, constructive and destructive. Now, if horizontal movement of water involves waves, second horizontal movement is ocean current. So, the second movement of ocean water goes with oceanic currents. We have referred it earlier, the ocean currents are river flow of ocean, which is always in a particular path. NCERT also reads that ocean currents are influenced by, I am slightly zooming it in, ocean currents are influenced by two types of forces, primary and secondary. Primary is that initiate the movement of water, and secondary that influences the flow of the current. And then it enlarges which are the primary factors. So, primary forces includes, so number 1, primary forces includes heating by solar energy, wind, gravity and Coriolis force. So, what is primary factor? Primary factors are those which initiate the movement of sea waves. And which are the primary factors then? The solar energy, the wind, the gravity and the Coriolis force. And if I talk about the details that is being given here briefly, so heating by solar energy causes water to expand, and that is the reason in equatorial region near equator, ocean water is about 8 centimeters higher in level than in mid latitude. Now you have to understand that there is a latitudinal variations in the height primarily because of solar energy. This causes very slight gradient and water tends to flow down the slope. Now if the water is flowing down the slope, what will happen? Comes in factor number 2, wind. Wind blowing on the surface of ocean pushes the water to move. The friction between wind and water surface affects the movement of water body in its course. Gravity, number 3 factor, tends to pull water down to pile and create a gradient variation. This gradient variation makes Coriolis force intervention and causes water to move to the right in northern hemisphere and to the left in southern hemisphere. And once you take these into account, it develops what is called Geyer circulation. Now you have to take the understanding of this Geyer circulation with reference to certain important diagrammatic representation. Let me make you understand it like this. I believe it to be one hypothetical ocean basin. What I notice is that due to the spin of the earth, there is the development of north and south equatorial currents. What are north and south equatorial current? Caused by spin of the earth. These are west moving, I am writing west moving equatorial water. These water tends to get piled up. Piling up where? Piling up on the western shoreline. Now this piling up basically is facilitated by trade winds. So I have to take understanding of trade winds effectivity. Northeastern trade, northeastern trade, southeastern trade. So water is piling up right here. So piled up water. Where? At west coast. And if I take reference of this lower latitudinal piled up water, what will come in? So piled up water will tend to create this type of a water mount. And in this type of the water mount, because of the gravity, so this is gravity, and Coriolis effect. Northern hemisphere, it is always on its right. I'll develop boundary current. Which boundary current? West boundary current. Mind it, piling up would not have taken place if trade winds would not have been there. So this is northeastern trade in northern hemisphere and this is southeastern trade in southern hemisphere. If I apply the same logic for the mid latitude, I reconstruct a bigger diagram so that I can generate all latitudinal goals. So this is my equator. We have already learned north equatorial and south equatorial current. We have learned west boundary current. And if I apply the same logic, will I be developing east boundary current? What will be east boundary current? East boundary current will involve the influence of westerlies. Northwest westerlies in southern hemisphere and southwest westerlies in northern hemisphere will again create the same piling up of the water which we attempted few minutes back. Piled up water, gravity transfer, Coriolis effect. Mind it, you are in southern hemisphere, so Coriolis effect will be on its left. So I'll be creating which boundary current? East boundary. What was these? West boundary. North equatorial current, south equatorial current, and then comes in Southern Ocean, circumantarctic drift, and in Northern Basin it will be called North Atlantic or North Pacific drift. Now what I need to understand with this is that once I take the polar water tends to make its move towards east. Northern hemisphere it goes northeast because of the continental boundary. Southern hemisphere it goes absolutely east because Southern Ocean doesn't have any continental boundary. If you just try to see this circulation now, have I developed a clockwise circulation in Northern hemisphere? So it is Northern hemispheric Geyer circulation and this is my Southern hemispheric Geyer circulation which is counterclockwise. And what are the constituents of each of the Geyer circulation? Constituent of each of the Geyer circulation includes, and I am repeating, west flowing equatorial water, higher latitude flowing west boundary current. So there should not be any prize for guessing. West boundary current is always warm current because it transports lower latitudinal water to higher latitude, and east boundary current in comparison are cold current because they transfer higher latitudinal water to lower latitude. This closed current system is called Geyer circulation. And every open oceanic basin, now this is also very important thing for you to understand. When I say every open oceanic basin, what does that mean? Atlantic, Indian and Pacific Oceans all will have south equatorial current, west boundary warm current, east boundary cold current, and circumantarctic drift. I'll be labeling it in a while. North Atlantic, Northern Indian Ocean, Northern Pacific will have north equatorial current and also west boundary, east boundary, west boundary and east boundary. Only in Northern Indian Ocean basin we don't see any such Geyer circulation, because Northern Indian Ocean is not an open. Now carefully notice, I have got Geyer circulation in 5 ocean basins and names of the currents, it's absolutely repetitive. I am highlighting Atlantic Ocean. What is the name of this west boundary current? It is Brazilian. Brazil, the country just neighboring. This is west boundary warm current called Gulf Stream, Gulf of Mexico. This is called east boundary cold current, Benguela. East boundary cold current, Canaries. We already talked about North Atlantic drift. Africa, Mozambique. You know, easiest way for you to learn. Imagine the map, this will be the landmass of Australia, and Australia East Australian current is actually a west boundary current of ocean. And what will be this? It is West Australian current. So West Australian current is which type of current? It is east boundary current in Indian Ocean. East boundary of the ocean. And right here you have got Peruvian current, which is also called Humboldt. This is Kuroshio. This is North Pacific drift, and this is California. It becomes significantly easy. Geyer circulation is closed current system of the surface water, which essentially is developed by spin of the earth, Coriolis effect, wind, gravity, all taken. I'll have west boundary and east boundary current. Now, which are the west boundary current? Gulf Stream, Brazilian current, Mozambique current, East Australian current and Kuroshio current. And which will be our east boundary cold current? It's Canaries, it's Benguela, it's West Australian, it is California and it is Peru. So Geyer circulation is closed current system, not getting to climate. Why it is so? That Northern Indian Ocean basin don't have Geyer circulation, because during summers wind is onshore and during winters wind is offshore. So until unless I have got consistent movement of wind, will there be these piling up made possible? No. And that is the reason I don't see Geyer circulation in Indian Ocean. Wrong. I don't see Geyer circulation in Northern Indian Ocean basin. All the points that I have highlighted as red blocks, ovals, is where we are having piling up and the development of boundary current because of consistent movement of planetary winds. Why Northern Indian Ocean do not develop this? Because Northern Indian Ocean is characterized with different seasonal wind pattern. If I now pick up NCERT, it reads types of oceanic current. It is classifying on the basis of depth. We are right now only talking about surface current. Surface current account for 10% of all the water movement, and it is confined only to the upper 400 meters. So 90% of the water is deep water current, which we have not talked about. And the surface water is further classified into temperature. Cold current brings cold water into warm water area. Cold oceanic currents are commonly found. Now this can be confusing, so you have to be very cautious with it, that if I draw a boundary line like this, I am taking NCERT now, and I believe this to be a continent. So west margin of continent is ocean here, right? So read it. Cold currents bring cold water into warmer area. These currents are usually found in west coast of the continent. So if I am in the west coast of the continent, will I not be on east coast of the ocean? This relativity has to be taken very cautiously. So there are two ways by which I can say where are cold currents. Cold currents, warm currents, NCERT says continent. So cold currents, if are in west coast of continents, they will be on which coast of ocean? East coast. And similarly, warm currents, which is on east coast of continent, will be on west coast of oceans. So just be very cautious with this expression, and I want to attempt it one more time, and I am referring this diagram again. This was our diagram, and if I just try to take reference of it, this is my Atlantic Ocean. So Atlantic Ocean in the western shoreline, Atlantic West will be east of South America. Relative, this is called relative location. So if I try to see it from the perspective of land, where is Brazilian current? Brazilian current is located on east coast of South America, right? And where it is, when I read it from Atlantic Ocean, it is west coast of Atlantic. Are you getting it? NCERT says continent based location. And what is the logical point with which we can apply? Ocean based location. So be very cautious with it. If I am on the west boundary of Pacific, right here, I am on the west boundary of Pacific. So I am on the east boundary of Australia. So what is East Australian current? It is on east of Australia but west of Pacific. And then our NCERT gives us what we have already taken in our understanding. Now you see it on map. And can you notice one by one? I am zooming in for Atlantic Ocean. Are we noticing North Equatorial Current, the Gulf Stream, the North Atlantic Drift? This can be called Norwegian Current. And are we noticing the Canaries East Boundary Cold Current? Similarly, South Equatorial, Brazilian, West Wind Drift, Benguela, South Equatorial, Mozambique. Mozambique is also called Agulhas. This is the name written in our NCERT. West Wind Drift is Circum-Antarctic Drift, and note this is West Australian, and do understand Australia west but Indian Ocean east. Now notice some of the currents that are being mentioned here. Counter equatorial current is retreat of the water. Labrador current here, or we have got Irminger current here. Similarly, Falkland current can be seen here. These are basically summer specific current. When during summers ice melts, they tend to generate these currents. So they are something that are specified, they are not always common. So are we noticing closed current system, clockwise northern hemisphere, counterclockwise southern hemisphere Atlantic, counterclockwise southern hemisphere Indian, and now zooming it out to get to the Pacific Ocean, it is South Equatorial Current and Humboldt or Peruvian Current and West Wind Drift. It is North Equatorial Current and California Current. I hope you are noticing it. And to see the other part, notice this. Kuroshio, North Atlantic. Oyashio is same and Ocost. This is Ocost current. Which type of current they are? Same. Summer melting. And right here, attempt the name of the current. I am in east of Australia. but west of Pacific. So what is the name of this current? East Australian. And which boundary current it is? West boundary. Becomes easier. Can we notice this? Geyer circulation on map of world is 5. North-South Pacific, North-South Atlantic and Southern Indian Ocean with cold and warm currents. Now, if I ask you to see one more part which is mentioned in our NCERT, though quite small one, thermohaline circulation. This is important. Thermohaline circulation accounts for 90% of ocean water movement. And it is involving all the water depth that is more than 400 meters of depth. And it actually incorporates 3 constituents, which are they? Upwell, downwell and benthic current. So can you notice that the blue arrows are being shown as cold water formations. Cold water is the benthic current which tends to upwell right here and moves as the surface warm water current. So red is warm water. Notice upwelling in lower latitude, upwelling in the higher latitude, cold water sinking in here. Why upwelling here? We have got the effect of boundary current. So see carefully. Cold water formation, downwell and then upwell. Thermohaline circulation makes global conveyor belt which is extremely slow and thus is non-existent from the perspective of human life. And that is the reason when I talk about thermohaline circulation or deep current system, deep ocean current system, it has got its significance from geological time perspective. And global conveyor belt is actually generating what is called the temperature, the salinity and thus the habitability mix for the ocean aquatic ecosystem. So it basically is a subsurface current system which accounts for 90% of the ocean water movement, but is not having that prominence from the perspective of human life, because if I say it's slow, how slow it is? It is taking thousands of years. The blue arrow which has been shown in this diagram is actually moving. The way I have just crossed the Southern Ocean like this, it will take thousands of years for us to cover certain kilometers of distance. So it actually is too slow. And please remind yourself of these terms thermo and haline. So it has to do with salinity and temperature. So dense or colder water tends to sink and warm water tends to upwell. So it has to do with the temperature and salinity. So if I have to quickly repeat the oceanic current system, so ocean currents includes one surface current that is primarily caused by spin of the earth, planetary winds, developing Geyer circulation. And there are 5 different Geyer circulation on the map of world, and 2 is a subsurface or deeper ocean current system that is called thermohaline. And does it sound logical that surface current system will make current horizontal movement of water, but subsurface do incorporate vertical component of ocean water as well. But when it comes to the vertical movement of water, then which is the water movement that is prominent? Let us get to that now. Tides are the bulge developed on the water surface due to the lunar and solar attraction. And because Earth is spinning on its axis west to east, every attractive bulge due to inertia tends to develop equal and opposite centrifugal bulge. That is the reason when we talk about tide, we say tide is a planetary wave which will have wavelength. So take this two-dimensional figure and apply, which will have wavelength running half the circumference of the Earth and wave height not more than 2 meters. I am repeating, what is tide? Tide is vertical movement of ocean water. How do I define tide? So point 1, vertical movement. What vertical movement of water that is developed due to lunar and solar attraction. But why tide always develops a planetary wave? Because every tidal attractive bulge due to inertia develops equal and opposite centrifugal bulge. And as I take the inertia which is caused by the spin of the Earth, so automatically at point here and point here I am having attractive and centrifugal bulge. So at these points I will be having depressions, troughs. So what will be the planetary wave? It will have a wavelength running half the circumference of the Earth and wave height crosses. These are the depressions. Wave height that will be not more than 2 meters. So planetary waves makes the definition of tides. When we talk about types of tide, we essentially distinguish between spring tide and neap tide. Now if you try to see the demarcation between spring and neap tide, so we are picking up position of sun, earth and moon. So taking this diagram one by one, I just want to create my own diagram. I can see this position of sun, moon and earth. Right here I have constructed it. This position, aligned position, is called Syzygy conjunction. And I can have another position that is again sun, earth and moon. This is also aligned position, but this is Syzygy opposition. Syzygy conjunction, combined gravitational pull of sun and moon is working on the one side. So I have got solar attraction and lunar attraction together on this side, right? And if it is Syzygy opposition, lunar attraction is here and solar attraction is here, opposite side. And mind it, every attractive bulge tends to develop equal and opposite centrifugal bulge. So equals solar centrifugal plus lunar centrifugal, and here it is solar attraction is with lunar centrifugal and lunar attraction is with solar centrifugal. Which type of tides are developed? Spring tides. So be very cautious with the point that spring tides, spring has nothing to do with season. Spring tide means additive tides. Being additive, they are high tides. What is adding to what? Now if you concentrate on this image is what I have constructed right here. If you can just see that point. When it is new moon, what is the position called? Syzygy conjunction, where moon and sun is adding to each other force at one given point, as in Syzygy conjunction will be related to new moon, and in this new moon position lunar and solar attraction will work together. So what is adding? It is attraction of both sun and moon to one side, and it equals centrifugal on the opposite side. So additive high tides are developed. It goes opposite when it is opposition. Opposition will be synonym to full moon. In full moon position, again I am in syzygy, it's again syzygy, it's not that we are not in aligned position, but because moon and sun are on the opposite side of the earth, so lunar attraction will combine with solar centrifugal and lunar centrifugal will combine with solar attraction. In both the case, there will be additive high tides. Want you to see this now. Sun, new moon, lunar tide, solar tide. Do notice I am shading lunar tides. Lunar tides are higher in height. So if it is new moon, solar attraction and lunar attraction are working together. But if it is full moon, lunar attraction will work with solar centrifugal. Which type of tides will be generated? Spring tide. And what are spring tide? High tides. And if you just try to take the first and the last quarter of moon, then the solar attraction and centrifugal and lunar attraction and centrifugal will be in perpendicular alignment to each other. As such, I will be developing neap tides. This perpendicular alignment, neap tides, will be low tides. Lunar attraction centrifugal, solar attraction centrifugal. Neap tides are quadrature tides. Spring tides are syzygy tides. Spring tides are always high tide. Neap tides are always low tide. In our NCERT, we are being given types of tides also on the basis of their frequency. So if I read that, types of tide vary in their frequency direction. Basically, it has to do with the fact that Earth, if would have been a perfect sphere, we know that we are geoid, number one, and that we don't have uninterrupted water. It is that we have got continental shoreline or continental barriers also. So point is that when I talk about tidal bulge, equal opposite centrifugal bulge, I don't develop that absolutely. That is the reason I do demarcate tides on the basis of modifications. So tides based on frequency is a semi-diurnal, diurnal and mixed tide. And how exactly do we distinguish between them? The definition is very well given in our NCERT. I will be attempting diagram. First I want to read it. The semi-diurnal tide is the most common tidal pattern. It has got 2 high tide and 2 low tide each day. Darnell tide is 1 high tide and 1 low tide, and mixed tide is, of course, it is also diurnal where we are taking 2 high tides and low tides, but the variations in the height, mixed tide. So tides by frequency have got 3 types: semi-diurnal, diurnal and mixed. And how do we define them? Let us try to understand it with the support of this diagram. 3 types of tides. I can attempt them like this. So I am plotting time here in all the 3 graphs. And it is height here. Height you can take it in meters. So this is 0 meters. Of course from the mean sea level. And we are picking up the time, so say 12 hours and then 24 hours. So 12 and 24 hours is what we are marking in our understanding in all the 3 diagrams, right? And height is plotted here as I have already said. Now, if I talk about tide as this, high, low, 1 high, 1 low. If I talk about tide like this, low, low, high, high. It is 2 high tides and 2 low tides. I'll call it and if the semi-diurnal is actually having variations, so let us try to attempt it. So see it, this is low, this is also low, this is high and this is also high, but the height is not similar. So which category it becomes? Mixed semi-diurnal. Because we are geoid and because we have shoreline. Uninterrupted tidal generation is not there. Tide facilitates variations and these variations generates 3 different types of tides called diurnal, 1 high, 1 low, semi-diurnal, that is 2 highs and 2 lows, and when I take reference of the other, that is mixed semi-diurnal, that means 2 high and 2 low, but the height of the tides are not similar. Saying this, carefully see this figure now. Generally on the map of world, which are the locations where we have diurnal tides? So notice diurnal tides are commonly seen in diurnal tides. Noticing it is Gulf of Mexico. And our NCERT also talks about the same. Yellow color. Let me not use my color so that it becomes easier for you to notice. See yellow color on the image. So diurnal tide is Gulf of Mexico. Diurnal tide is Sea of Okhotsk. Noticing it here, it is South China Sea. So it's diurnal. And the red color is semi-diurnal and I have got it in the entire Atlantic Ocean shoreline. So entire Atlantic Ocean shoreline. I can also see it in both the side, west as well as east. Noticing it, I am highlighting it here. I am also using red color. I can also see it in Bay of Bengal. And if I take the mixed tides, the blue color, Arabian Sea. So Bay of Bengal is going with semi-diurnal and mixed semi-diurnal tide is more with Arabian Sea. Are you noticing it is right there with Pacific shoreline? Which Pacific shoreline this will be? East Pacific. So this can be taken up as examples because tidal bulge is created by lunar and solar effectivity, but you need to understand that we don't have uninterrupted water. There is land mass which is creating the barrier. So that automatically tends to mobilize 3 different types of tides. So diurnal shown as red color, yellow color here. Semi-diurnal which is shown as red color here and the mixed semi-diurnal which is with blue color. So I can notice that the Pacific shoreline has got the prominence of it, whether I am in the Southeast Pacific, East Pacific, West Pacific or even towards Equatorial belt. Atlantic is largely with the semi-diurnal tides. And in Indian Ocean, in our country, Bay of Bengal is essentially semi-diurnal and mixed semi-diurnal is with Arabian Sea. So Arabian Sea, Gulf of Kutch, Gulf of Khambat, and with the Bay of Bengal we have got the Sundarbans tidal energy harnessing possibility. So we classify tides on the basis of mechanism. On the basis of mechanism there are 2 types of tides, spring tide and neap tide as per our NCERT, and in terms of its frequency we classify tides into 3 categories, which are they? The diurnal tide, 1 high, 1 low, the semi-diurnal tide, that is 2 highs and 2 lows in 24 hours of time, and mixed semi-diurnal tide. It is same as semi-diurnal with 2 highs and 2 lows. However, we have got variations in the height and the depth of the created tides. I hope it will help you in revising this chapter of your NCERT. Please do the same. Take reference of this video and these important figures that I have created and try to read. I have not mentioned, our NCERT also talks about importance of currents and importance of tides, that you can easily have a read there. I have focused more on the mechanism. So happy learning to all of you. All the very best.